with the information given or already calculated, it's possible to find the distance from the ground when the arrow hits the target, the time it takes for the arrow to hit the target, and the angle that the arrow hits the target. And our knowns are gravity is negative 9.8 meters per second squared. The angle at which the arrow is released is 0 degrees, which means it's just shot horizontally. It's released 1.5 meters off the ground, so that's the initial y value. The initial velocity is 43.8 meters per second, and the distance the arrow travels in the x direction is 6 meters. So first we can calculate the change in time by using a kinematic equation, projectile motion equation, and the only requirements for using this is that acceleration is constant, and it is constant in the x direction. We use the equation change in x equals velocity initial times time plus 1/2 acceleration times time squared. And then because acceleration in the x direction is 0, we get 6, which is the distance traveled, equals 43.8, which is the velocity initial, times time. And after rearranging it, we solve and get that change in time is 0.137 seconds. And now that we have time, we can solve for how far the arrow was off the ground when it hits the target by using the trajectory equation, where it's y equals velocity initial times time minus 1/2 gravity times squared. And plugging in the numbers, you get y equals 0 times 0.137 minus 1/2 negative 9.8 times 0.137. And simplified down, it's easy because the velocity in the y direction was initially 0, and you get y equals 0.092 meters. But this number is the distance that the arrow traveled in the y direction. So originally it was 1.5 meters off the ground, and it traveled 0.092 meters down, which means that the arrow was 1.408 meters off the ground when it comes in contact with the target. And now that we have this number, we can solve for the angle that the arrow hits the target by just using right triangle trigonometry. You can draw a right triangle where the hypotenuse is the arrow path, and then the theta is the smaller angle in the triangle, and the adjacent side is 6 meters, and the opposite side is 0.092 meters. And using inverse tangent, we get that the arrow was hit the target at 0.88 degrees below the horizon. And this angle is obviously really small, but it makes sense because it traveled 6 meters in the x direction, but less than 0.1 meters in the y direction.